So we're going to begin our coverage tonight with an overview of the ImageTaskGang application. And we'll start out by explaining what the ImageTaskGang application or applications are and the various patterns that they apply. And you'll see there's actually two implementations of this. One of them is available in the link at the bottom of this slide, and that's the so-called command line version. There's another version we'll talk about that is an Android version. I'll explain shortly why we have two different versions. So let's start by giving an overview of what this particular application does. What this application does is it shows how something called the TaskGang framework can be customized to download, process, store, and display images concurrently. And if you take a look at the link at the bottom of this slide, you can get a link to the GitHub repository project that contains the source code for the Android version. So let's take a look and see how you can use the Android version. So what you can do here is you can provide default URLs, you can add your own URLs and so on. There's different ways you can do that. And then you can click a run button. And what will happen at that point is that the images that you have designated will be downloaded from the remote server or locally if that's the configuration you choose. And then some filters are applied to the images. Now, one of the filters is the so-called null filter, which doesn't do anything as the name implies. We just kind of put that in there to show what the images look like when they're downloaded. But there's also another filter, which is the grayscale filter. And as you can see, it applies the grayscale algorithm to get rid of the color. The images are then stored, whether they're the null filtered images or the grayscale filtered images, they're stored in a persistent data store locally on the device, which in this case would be an Android phone. But there's a command line version as well that just stores it on the local computer, like a laptop or a desktop and so on. And then various Java collections and thread pools are applied throughout the program. So there's a list of URLs to download, which can come from various sources. We'll talk about that later. There's a list of filters to apply, and it's an open-ended list, so you could add other filters. You could add a tint filter or an emboss filter or a sepia filter or whatnot. And there's also a couple of different pools of threads, and we'll talk about them. There's a fixed size pool of threads, and there's also a variable size pool of threads using something called a cached thread pool. Now, there's also various concurrency strategies that can be applied. So let's kind of talk about that because that's naturally one of the main focal points of this course. So we have the executor model, which is either a fixed size or variable size thread pool. We have what the unit of concurrency is. In this case, the unit of concurrency is a task is used for each URL to download and each image filter to apply. And then the last piece of this strategy puzzle is the results processing model, which uses an asynchronous future model to process the results as soon as they occur. And we'll talk about that when we get a little further on into the walkthrough, showing the patterns and showing the implementation details. As I mentioned, there's a command line version as well as an Android version. We're going to focus on the command line version just because it allows us to use more of the modern Java features, because we can use the latest and greatest version of Java, rather than the Android version, which, as you've discovered, is kind of limited to sort of Java 11. I've heard there's some rumblings that Java 17 is going to be supported at some point, but I don't think that's happened quite yet. So something else to keep in mind here, which is really fun, we use a bunch of Gang of Four and pattern-oriented software architecture, or so-called POSA patterns, to enhance the framework-based ImageTaskGang implementation. And you can learn more about these patterns at the link at the bottom of the slide. The patterns that are most essential to the design that we really care about, which is the concurrency part, are patterns from the POSA book series, the proactor pattern, the future pattern, and the pooling pattern. The proactor pattern, which was first published in a book form in the POSA 2 book, where I was the lead author, separates the initiation of asynchronous operations from the handling of these operations, allowing for more scalable and efficient event-driven processing. The future pattern provides a proxy for a result that may not yet be available, thereby allowing a program to continue execution without blocking until the result is absolutely needed. And then there's also something called the pooling pattern, which appears in a couple of places. It appears in the POSA 4 book and the POSA 3 book, which involves creating and managing a pool of reusable resources, in this case threads, to improve performance and efficiency by reducing overhead that's otherwise associated with creating and destroying resources repeatedly. So we simply pool stuff. And there's lots of other kinds of pools. You can have connection pools and memory pools and things like that. There's also several gang of four patterns. These are patterns from the Design Patterns Elements of Reusable Object-Oriented Software book that you're all familiar with. It's sometimes called the GOF book or Gang of Four book. These include decorator, factory method, and template method. And the decorator pattern allows a behavior to be added to an object dynamically, thereby providing flexible and alternative combinations of features without having to modify the underlying object. There's also the factory method pattern, which defines an interface for creating objects, but allows subclasses to decide which concrete class to instantiate, thereby promoting looser coupling and more extensibility. And we'll see there's some variants of that. They don't always require subclassing in particular. And then there's also the template method pattern, which is another gang of four pattern that defines the skeleton of an algorithm in a base class and allows subclasses to override certain steps in that algorithm while keeping the overall structure intact, thereby enabling code reuse and finer grained levels of customization. There are also use of singleton and command patterns throughout the implementation in more limited ways. They're not quite as strategic to what we're doing here. The singleton pattern, as you may be aware, is an infamous pattern that ensures there's only one instance of a class that's created, and it gives a global point of access to this one instance. And it's typically used where you have a single shared resource that needs to be managed and created on the fly when it's needed and only when it's needed. And then finally, the command pattern encapsulates a request as an object, allowing the parameterization of clients with different requests, queuing or logging requests, and supporting operations like undo and redo. There's also a variant of the command pattern called the command processor pattern that appears in the POSA 1 book. We're not really going to talk about that a whole lot here, but it's also relevant. So that's the end of our overview of the ImageTaskGang application.